Two more problems to do here for this lesson. Take up a couple of interesting types of problems. The first one is that we're going to take two sets, 2 points, and see if the lines that pass through those points are parallel or perpendicular or neither of those two, which would just mean they either don't have the same slope or they're not negative reciprocals of each other. That could be the case. And then 2, we're going to do a little coordinate geometry here, where we're going to have the triangle LMN, and we're checking to see whether or not this angle right here is a right angle. And that would make this a right triangle, which means special rules apply. We're going to check the slope of line LM, or line segment LM, and line segment N, and M and N. And if those two have negative reciprocal slopes of each other, then that is a right angle and this is a right triangle. So we're going to check on those two types of problems and look for parallel or perpendicularism. And in this case, we're checking for perpendicularness, which means 90-degree angles. So I'm going to move over to the other camera, work those problems out on some grid paper, and then we'll be done. Okay, here's our first problem with our the endpoints of some line segments. And so I think that a good way to start this is just to kind of get a visual of where these points are. And we'll take some guesses. So the black dots are the first one. We've got -2, 2, and 2, -4. And then our other set of dots here at 3, 6, and at 5, 3. And if we go ahead and we connect those dots, draw a line through those 2 dots, or sets of dots, they look kind of parallel, I have to say, but we got to do the number crunching. We got to do the number crunching and see if that's really what they are. I'm a horrible straight line drawer. I apologize. So how do we do this? How do we find out for sure? Well, we use the distance, not the distance formula, we use the slope formula that m equals y2 minus y1 over x2 minus x1. We're going to do that with each set of points here. So this one up here for starters will be x1, y1, x2, and y2. And let's just plug those values in to our slope formula. y2 is -4, y1 is 2, and on the bottom x2 is 2, and x1 is -2. Okay, check this, make sure I did this right. And if that's the case, then we get a slope here between these two lines of -6 over 2 plus 2, 4. -6 over 4 or -3 over 2. Okay, we're just going to let that sit there. We're going to move on down and we're going to do it again. M is y2 minus y1, x2 minus x1. And our new points here, this will be our x1 and our y1 and our x2 and our y2. So if we plug those in, y2 is 3 minus y1, which is 6. And then on the bottom, we're going to have x2, which is 5, minus x1, which is 3. 3 minus 6 is -3. 5 minus 3 is 2. And we see that their slopes match, and that means that those two lines that go through those dots are parallel. Okay, that's problem number 1. We proved it algebraically, and we took some guesses at it geometrically, though my guesses were probably pretty lame there as far as going through the dots. Second problem is coordinate geometry. And one of the things we have to do here that sets it up exactly like that last problem, again, this time we're checking for perpendicular, is we have to identify the points on the coordinate system. So we have to say what point L, or the vertex at L, where it's at. And it looks like it's at -3 and 1. And m is here at, looks like -2, -3. And n is at +2, -2. So we're going to have two sets of dots here. We got what they call line segment LM, and that is defined by these 2 points right here. And we have line segment MN, which is defined by these 2 points right here. So we're going to do the exact same thing. We want to find out what's the slope of that line. We don't care about the whole equation of that line. We just want the slope of that line segment and the slope of this line segment here. Okay, so let's get that set up. Let me erase my board. We'll work that problem out. Keep all that business right there just so we kind of have it handy. And here we go. We want to know what the slope is of line segment L to M. So point L, -3, 1 is going to be our x1, y1. And point M, vertex M, which is -2, -3, is going to be our x2, y2. Honestly, it doesn't matter which one you pick to be the first one and the second one. The math comes out the same. So slope is y2 minus y1 over x2 minus x1. Again, this is the slope of LM. I'll plug in the details here. y2 is -3 minus y1, which is 1, over x2, which is -2, minus x1, which is -3. So we do the math here. -3 minus 1 is -4, and -2 minus the -3 is -2 plus 3, and that's 1. So there's our slope for that first line segment, -4. Now, in order for these to be right angles to each other, for this to be perpendicular, we're going to need the negative reciprocal. So let's just predict what that is going to be right now, and that's what we're going to look for. We change the sign and we flip that fraction over from 4/1 to 1/4. So this is the slope we're looking for our other line segment to check for perpendicularity. So let's do that. Let's go line segment MM slope. That'll equal y2 minus y1 over x2 minus x1. And we've got our new points here. Now M was -2, 3, -2, -3, and N is 2, -2. So we plug those things in. This is the second one. You're number 2, you're number 1. Here we go. y2 is -2 minus y1, which is -3, divided by x2, which is 2, minus x1, which is -2. On the top, we get -2 plus 3, -2 minus -3, -2 plus 3, and that equals 1. And on the bottom, we get 2 minus -2, or 2 plus 2, which is 4. And there we do it. We got our thing that we're looking for, 1/4, positive 1/4, the negative reciprocal of -4/1. So both of those are related to each other. We know now that on this picture, for sure, it kind of looked like it, but now we know that that is a right angle right there. And now we can do some, Pythagorean theorem kind of stuff to that geometry problem. That's it. Enjoy. We'll be seeing you soon. Make sure that on the next set of things you make sure that you're ready to go for that. Peace out, homies.